Hello friends, welcome to a fresh new episode of our channel RG Innovations. If you have not subscribed already, please subscribe to our channel, click on the bell button and select all to get all future notifications of our video uploads. In today's video, we are going to discuss about NTC Thermistor Module. Thermistor or a thermal resistor sensor module is used to sense temperature and convert it into output signals. It is associated with both analog output pin and digital output pin labeled as AO and DO respectively on the board. Thermistor sensor module is made of semiconductor materials. Basically, thermistor sensors are mostly negative temperature coefficient or NTC, which means NTC thermistors will have their electrical resistance decreased when subjected to an increased temperature. In the picture, we can see an NTC thermistor. This black part is the thermistor. Here are the connecting pins. The first one is the analog out pin. The second one is the ground pin. The third one is the positive power supply or VCC pin. And the fourth one is the digital out pin. The heart of the module is LM393IC, which compares the voltage coming from the thermistor and gives the analog output signal. Here is also one potentiometer. Its value is 100K. It is used to adjust the sensitivity of the potentiometer, and it is also used as a reference potentiometer to calibrate the temperature sensor. We will see both the functions of this potentiometer in the practical demonstration. There are two types of thermistors. Positive temperature coefficient or PTC. The PTC thermistor resistance increases as the temperature increases, and the negative temperature coefficient or NTC. The NTC thermistor resistance decreases as the temperature increases. In our module, we have one NTC thermistor installed. The specification of the NTC module is the operating voltage of this module is between 3.3 volt and 5 volt. The functional temperature measurement ranges between -55 degree and 125 degree centigrade. This module has an accuracy of ±0.5 degree centigrade. Now let us have a look at the circuit diagram. It is very simple. We have given power supply from the 5 volt pin and the ground pin to the ground pin and the positive power supply pin of the module, and we have connected the digital out pin to the digital pin number 2 of the Arduino and the analog output pin to the analog input pin 0 of the Arduino. Now we will have a look at the sketch and then we will see the practical demonstration. This is the Arduino sketch that we are going to use in the demonstration. Everything is commented for your easy understanding, but still I'll explain it in briefly. We have taken pin number 13, that is the built-in LED pin of the Arduino, digital input at pin number 2 and analog input at analog pin 0. Now we have declared some variable for using throughout the program, declared the pin mode in these statements. Also we have initiated the serial communication, and in the loop section we have read the analog value in the A0 pin, then we have printed that in the serial monitor. Since the output is reversed in the A0 pin, we have reversed it using the map function of the Arduino. Then we have created a function called thermistor. Here is the function. By this function we have converted the analog value to centigrade temperature and then the centigrade temperature to the Fahrenheit temperature. Then we have read the digital input. If the digital input is high, the LED will turn on, the built-in LED, and if the digital output is low, the built-in LED will turn off. Then we have printed the temperature in Fahrenheit and centigrade. We have delayed for 1 second and then this process repeats. And this thermistor function is used to convert the analog value to the temperature. So this is our Arduino sketch. Now we will connect the Arduino with the computer and upload the sketch and see the practical demonstration. So this is our prototype of the circuit that we have shown. This is the NTC module and this is the NTC thermistor. Now we will connect it with the computer and check the output. So I am connecting it with the computer. You see, as soon as I connected it with the computer, the power LED of the module is glowing. It means the device is working. Now we will go to the Arduino sketch, upload the sketch and see the output. I am uploading the sketch. While the sketch uploads, I am going to half and half display, opening the serial monitor, and you can see it's showing the analog value of the module, digital value of the module, and LED is off. Measured temperature is in centigrade and Fahrenheit. This is showing the temperature 77.8 in Fahrenheit, but it's not the actual temperature. We have to calibrate it by using the potentiometer to set the actual temperature. So I have to check the temperature from a thermometer and then adjust it by this potentiometer. This module can be used in two types. one for checking the current temperature and another to perform some action when a certain temperature is reached. For the first type, for reading the accurate temperature using it, we have to adjust this potentiometer to the current temperature so that it can increase and decrease along with the temperature increase and decrease. So I have to check the temperature, current temperature, using another thermometer for the calibration of this module, and I checked it in my clock. The current temperature is around 91 degree Fahrenheit. So I'll turn it and set it to 91 degree Fahrenheit. So I am setting it at 91 degree Fahrenheit. You see, when I am setting it at 91 degree Fahrenheit, the output LED here is glowing, and I have connected an LED parallel with the built-in LED of the Arduino, so that is also glowing. Here you can see the built-in LED of the Arduino is glowing, and this LED is connected in parallel with the built-in LED, so this is also glowing. It is because the digital out pin has crossed the threshold temperature, so this LED is glowing. But when we are using it to read the current temperature, the digital out pin is of no use, so we can ignore this digital output. Now how can we understand that the temperature is increasing? I have my soldering iron which is hot now, so I'll bring the soldering iron close to the thermistor. You can see in serial monitor the temperature is increasing. Now if I remove, it will again decrease to the preset temperature. You can see this is decreasing bit by bit, and it will reach up to where I have set the temperature to. The module has heated a little, so it is taking some time to reach the preset temperature, but slowly it will reach the preset temperature. So this is the first type of use of this module, where we can use it as a temperature sensor. Now if we want to use it as a temperature limit switch, in that case the digital out will come into work. Then we have to decrease the sensor below the threshold point. So we will turn it anti-clockwise to decrease the sensitivity. You see, I am turning it. The LED turned off, output LED turned off. Here also this LED turned off. So it has reached below the threshold point. Now the temperature is showing 80 degree. Actually the threshold point of this module is set at 80 degree approx. So whenever it crosses 80 degree, the digital out will turn on. So if we hold the thermistor by hand, it will take our body temperature and the output LED will turn on. And once we leave this, the output LED will turn off. Also this LED will turn off. So the threshold point has been set at approx 80 degree Fahrenheit. Now what if we decrease it and set the temperature somewhere around 60 degree? Let us decrease this and set the temperature up to 60 degree. The temperature is now set to 63 degree Fahrenheit. Now this thermistor need to be given approx 20 degree more temperature to reach the threshold point and the LED to turn on. Now if we hold this by hand, this LED now will not turn on, because the difference of temperature between the thermistor and our body temperature is not 20 degree. So we have to bring something of higher temperature which has a temperature difference more than 20 degree than this thermistor's current temperature. So again we will bring the soldering iron. See, I am bringing the soldering iron close to the thermistor, and it got a temperature difference of more than 20 degree, and the output LED turned on. If I remove it, the temperature will go away and it will turn off very soon. See, at the threshold of 80 degree, the output turned off. So in this way we can use this module for two purposes. One is for monitoring the temperature, and one is to use it as a thermal limit switch. Hope now there is no confusion about this temperature sensor module. Still, if you have any question or any query, please ask me in the comments. I'll definitely try to answer your question. Today, up to this. If you like my video, please hit the like button and do not forget to subscribe my channel RG Innovations. We will meet again in a new video. Till then, bye bye, take care, have a nice time. Thank you for watching.